All right, everybody. Hello and welcome. So I just wanted to give you some information about how to use StatCrunch and walk you through a couple of homework problems so that you can get the sense of how to do this. The videos that I posted give you a good understanding of the concepts that we're talking about, but sometimes it can be a little hard to take those concepts and then translate them into homework problems. So first of all, the videos inside Canvas are very informative, but also it's really important that you watch the videos that are here in the Chapter 4 part of the My Open Math. Of course, you should be browsing through the textbook as well, but these 3 videos, and they're not very short, it's a little over 30 minutes to watch these 3 videos, very helpful and very much targeted towards the type of homework problems that you're going to be doing. So I highly recommend that you watch these, okay? And then we're going to jump into the Chapter 4 homework assignment right down here. So let's click on that. I'm going to come up. I'm going to do the teacher preview. And so what we have here, let's look at problem number 1. In fact, let me blow this up a little bit here. Let's make it like that and maybe do something like that. Okay, so area under the curve part 1. Find the probability of each of the following. So if we have, this means here, we have a normal distribution, that's capital N. Remember, a normal distribution means symmetric and bell-shaped. So it's kind of that, they call it normal because it comes up a lot. The symmetric bell shape. We'll see one in just a second. This means that the mean is 0, and this means that the standard deviation is 1. So that's what we call a standardized normal distribution. That means that the mean is 0 and the standard deviation is 1. And we'll also look at problems where it's not normalized. Okay, so we're going to do a couple of these. So what this means is, right, we want to know that the probability of a z-score falls in a certain range. And remember, a z-score, if you've been watching the videos that you should be, a z-score is a measurement of how many standard deviations a data point is away from the mean. So the higher your z-score, the higher that data point is further away from where most of the data points are located, and that makes it a more unusual point. Okay, so in the different videos, because stats is sort of in a period of transition, some people are still using the old ways. I'm going to show you how to use StatCrunch for these types of problems. So in some of the videos, you saw a table being used. Sometimes they were calculating things with a formula. We get to use StatCrunch to do a lot of the work for us. So I'm going to bring StatCrunch in here. And what you're going to do is go over here to where it says stats, and then it says calculators, and you're going to grab the one that says normal. So we come down here, grab normal, and it looks like this. That is a normal distribution. See, it's symmetric and it's bell-shaped, right? Symmetric and bell-shaped. That's a normal distribution. And this is going to do a lot of that calculating for us, so we don't have to look in tables like they did in some of the videos. So notice how it already starts off when they give us this. It's already set for a mean of 0 and a standard deviation of 1 because that's that standardized normal distribution. It comes up very frequently. So they just say, well, let's just assume people are going to start with that. But if you need to change it, you do. If you're doing a problem where it says the mean is 135, you just come down here and change the mean. If it says the standard deviation is 18, you just change it to whatever it is that you're trying to do. So we make sure that let me move this just so we can still see the problem. We've got a mean of 0. Okay, we've got a mean of 0 down here in StatCrunch. We've got a standard deviation of 1 in the problem. We've got a standard deviation of 1 on our calculator. So we're all set to go. Now we just have to make this line down here match this up here. So it says we need to know the probability that the z-score is less than negative 1.35. So notice here you can change the direction of the inequality. Whoops. Can't quite see it. If we drop this, you can see the direction of the inequality, or you can change it. Okay, we want less than to match this. Don't worry about the less than or equal to. There's some interesting math that we don't need to get bogged down into, but for this case, the less than is basically equivalent to the less than or equal to. So then I'll just put negative 1.35. We make this a little smaller maybe. Hit compute. And now it gives you a picture, and you should always look at the picture and just double check if the picture makes sense logically for what you're trying to do, because it's very easy to accidentally click the symbol the wrong way or something. It's telling us the answer is 0.0885, And they're telling us what? Round to 4 decimal places, so 0.0886. So we hit this, 0.0885. Wait, did I round? 1, 2, 3, 4. 1. Yeah, 1, 2, 3, 4. Oh, yeah. 0.0885. So it does match up our values. Right? So you can see that we're getting the right answer there. So now it's saying z greater than 1.48. Okay, so all we have to do now, turn this inequality around, and then we change the number. 1.48. Hit compute. We get that. And sure enough, same number, right? We can see they're matching up here. Okay, what about this one? We need a z-score that's between 2 values. Well, if you look up here on the calculator, there's a between button. We hit that, and you're just going to put these numbers in here. So negative 0.4 and 1.5. Hit compute. And see, now we get this segment that's cut off on both sides. But this number, guess what you're going to see over here? It matches up. Right? So this StatCrunch normal calculator will go through and calculate these z-scores for us. This is giving us the probability of these z-scores occurring in the way that you've been talking about z-scores or watching in the videos where they talk about z-scores. What about this one here? The absolute value of z greater than 2? Well, what that means is, let's go back to standard. That means that we want to include the area where z-scores are greater than 2 and the area where z-scores are less than negative 2. So you would just go 2, compute, calculate this, like write this number down, and then go less than negative 2, hit compute, write this number down. You'll notice in this case they happen to be the same number. Sometimes they might say, they can make it more complicated than that. Add up the 2 numbers and you're good to go. Okay, so that's how you do that problem. All right, let's take a look here. Okay, we've got question number 3. So GRE scores, part 2. Assume that scores on the verbal portion of the GRE follow the normal distribution with a mean score of 151 and a standard deviation of 7. So the problem that we just did had a mean of 0 and a standard deviation of 1. Here they're giving us different values. And then they say, while the quantitative portion of the exam has scores following the normal distribution with mean 153, standard deviation 7.67. So now when we come down here, they say, find the score of a student who scored in the 80th percentile of the quantitative reasoning section of the exam. So in the video, you learned that the 80th percentile means that 80% of your data is below that value and 20% is above it. So we want to find the part in our distribution here where 80% is below a number and 20% is above it. So let's take the values. Let's see. For this one, they say quantitative. So you have to read carefully in the problem which set of numbers you're using it. Here they tell us while the quantitative portion has values. So I'm going to change the mean, 153, and standard deviation, 7.67. Now this part we have to think our way through, and this is why it's going to be helpful to look at the picture that it makes us. We want 80% of our data to be in the red colored in region, and then we want 20% above it. So we want to know, this time we've been putting in a probability. This time we want to come up with we've been putting in a z-score value. We want to put in the probability. So here I'm going to put in 0.8 and hit compute and see the picture we got. 80% of our data is the colored in red part. 20% of our data is over here. That is what the 80th percentile means. So we got this number right here, 159.45523. And let's go over here and see 159.46. So we're getting that right answer over here after you round, right? So that's how you do that problem. The normal calculator is going to do it for you. It's important, don't just memorize how to put the numbers in there. Understand what you're doing. But if you understand what you're doing because you watched the videos and you took your notes and everything, then this calculator makes the actual calculations very easy. Okay, let's go down and look at question number 8. Okay, so question number 8 is a little bit different. How do you know it's different? Well, let's read it. Data collected by the Substance Abuse and Mental Health Services Administration suggests that 69.7% of 18 to 20-year-olds consumed alcohol beverages in 2008. Suppose a random sample of 10 18 to 20-year-olds is taken. Is the use of the binomial distribution appropriate for calculating the probability that exactly 6 consumed alcoholic beverages? So this, you will have seen this in the videos, so you can verify whether you meet all the conditions that are necessary for using a binomial distribution. In this case, it's yes. It answers all of it. Now, notice they're talking about a binomial distribution. So we're not going to use a normal calculator anymore because we don't have a normal distribution. We have a binomial distribution. So we're going to close this. I'm going to go back into Stat, grab a calculator. Oh, and look, there's a binomial calculator. You can't quite see it. There's a binomial calculator right here. Well, that sounds like it might be very convenient for the problem that we're working on. Let's try it. Okay. So notice this looks a little different because it's a different distribution, but now we have a binomial distribution that we're going to work with. Okay, so we have to put in some numbers. So we've got, they're saying, calculate the probability that exactly 6 out of 10 randomly sampled 18 to 20-year-olds consumed an alcoholic drink. Okay, so our N is 10. Because it's 6 out of 10. This is going to be 6. And notice we have some options here to choose from. Less than, greater than, equal to, less than, greater than, equal. We want equal in this case because they're saying exactly 6 means equal to 6. And the probability we have to steal from up here, 69.7 as a probability is 0.697. And we hit compute. And we get 0.2029488. And if we go over here, that number looks familiar, right? 0.2029. Okay. What is the probability that exactly 4 out of the 10 18 to 20-year-olds have not consumed an alcoholic beverage? So what you're going to do there is you're going to find the probability using the binomial calculator that if exactly 4 did not consume alcohol, that means exactly 6 did. So that's actually also, that's the same problem we just did. What is the probability that at most 2 out of 5 randomly selected 18 to 20-year-olds have consumed alcoholic beverages? So now our N is changing to 5 because we're grabbing 5 people. The probability isn't changing for each individual one, but we have to say here, at most 2 means less than or equal to 2. 0, 1, or 2 means at most 2. So then we go here, we hit compute, and we get our number over here, 0.1671. It matches what we're getting over here once you round. Okay, so that's how you use the normal and binomial calculators to help you do these probability problems. Thank you.